Hello, Ivan Barnash is here for the assignment 2 explanation video. Here I prepared the data set of COVID-19 symptoms and diagnosis. This is the diagnosis, this is the target column, it's true false, as you can see, and here are the features. Here I left some info about it, if you want to read it. Here I am reading the CSV first, then I wanted to see with value counts and I just wanted to see how many percent of entries in the data frame were actually diagnosed with the COVID, right? So to see if it's like skewed, if the data is imbalanced or not. As you can see, it's evenly distributed actually. It's 50%, see, like 50-50 diagnosed with positive and negative, which is great because we need balanced data. Then I'm printing the head, just a rule of thumb, always do that. And I'm creating a Boolean map and mapping these features because these features are true false, right? Then here I'm assigning X to the feature columns, as you can see, and Y to the target column infection probability. Then here I'm splitting the data as per the requirements, 30%. Now here I am initializing the decision tree. I am fitting the data and predicting here, and then printing out the accuracy score, confusion matrix, and classification report. What we can see from that is it's not great. It's 55% only, and same with recall, precision, F1 score. As you can see, it's not very impressive scores, but it figures. It figures. Why? Because as you can see here, there's not a lot of entries. First of all, it's only 2,500. And also features are very they do not correlate strongly with COVID. Yeah, so many other illnesses have same symptoms. Runny nose, fever, body pain, and difficulty breathing, so they don't correlate much with COVID, and that's why it's so incorrect, right? Because the like poor data pretty much. Features not correlate strongly with the target, and uh, not too many entries. So it's only natural. It's 55 only. Okay, then let's go to the part B. And part B, we just needed to do a lot of operations with the data of assigned to CSV file. So here I'm reading the CSV file, head, rule of thumb, right? Then first one, I'm dropping the model with the df drop, right? And here I'm checking it with this command, and it's false. So here we go. This is the check right here. Here I needed to strip the this cost column to make it non-numerical, like remove all non-numerical values. As you can see, dtype, it didn't change. Dtype is still object string, right? Now here I needed to convert it to integer. I'm doing just that with this little method, right? S-type string and sorry, S-type integer. And here displaying the D-type integer 64. Here we go. Then for A, I'm computing the average cost. So this is going to be a mean of cost column. Here it is. And then here I'm getting the mean for each continent, right? With the group by method here. Yeah. So why are we doing it? Because maybe we need it displayed like so group by becomes really convenient if we want to display maybe for many unique values in a column, the average of some other columns values, right? Now here 5, I'm displaying the mean of numerical columns by continent here with plot, and yeah, means just grouped by continent and computed means, and that's it. And 6, we needed to count values in the continent. As we can see, value count, so it shows us all the unique values in the continent column, right? And how many times it's there, like how many times we see it there. So North America 144 times, and as you can see here, there's only 7 unique values inside the continent column. And as we can see here, I'm printing it as well here. So here I'm printing with this little method unique. I'm printing all the unique values that's in the continent column. Here are all of them, and here I'm counting them with n unique number, unique values, 7. Right? Then we're doing the same thing with the cost. We are counting the as I said already, we're counting the unique values, how many times we see them in this column. For example, 56 we see 20 times in column cost. And then we are plotting the data for cost. Why are we doing it? Well, in real world, we always need to visualize our data before actually doing anything with it, right? Um, we need to see if the data is imbalanced, if it's skewed, if it's maybe, you know, if there are outliers in it. So there can be many things, and we sometimes need to, do some manipulations with the data. We need to do some, um, how do I say it? This word, transformation, right? Structural transformation. Uh, okay, so here in 10th, I'm summing how much non-values is in each column, right, of this data frame. And first, I'm actually counting how many non-values is in these 2 columns. So 9 and 2, and here we can see only in type and zip code there is some. Now here I'm filling these missing values with XXX, so I'm printing first nan is 2, then as we can see XXX is 2. Sometimes we need to do that because non-values, they screw up the data. And here we are dropping the nan values. So as we can see, there was 950 rows, then there were 9 removed after this method, right? So why we need it? Because sometimes we don't want missing values completely in our data set, so we need to clean it up, right? Now here I'm describing I'm just describing the whole DF. I'm putting it into the statistics, and I'm taking the first row and third column value, right? And it's 950. And here, uh, here I'm counting values of a continent, right? How many, I already said that, right? The unique values and how much we see them. Then I am making that a new data frame with this method, reset index. And here, why did I do that? Because I need to then sort it. Here I'm sorting it, right? And displaying, and as we can see here, so neatly displayed. Okay, that was the explanation. So we did a lot of structural transformations in here. Okay, thank you.